Question 17, our final video for today. And we've got another completing the square and some more graph sketching. So, we're given x squared plus 2x plus 3 and told that it's identical to x plus a all squared plus b. And we're asked to find the value of the constants a and b. So, in part A, we have to complete the square. Half the linear coefficient goes inside the bracket. Subtract the square of this. Don't forget any other constants. One squared is 1, subtract it, minus 1 plus 3 gives us a total of 2. We therefore know that A equals 1 and B equals 2. In part B, we're asked to sketch the graph indicating the coordinates of any intersections with the axes. From this, I know that the minimum point will be at minus 1, 2 in this quadrant. I know from the expanded form of the equation that the intercept will be at 3, or its coordinates 0, 3. Given that this is positive, if I took it to the other side to square root it, I'd end up square rooting a negative. I know from this that there are no x-intercepts, also from the location of the minimum point being at minus 1, 2. It's above the x-axis. General shape, positive, it fits, and we're done. In part C, we're asked to find the value of the discriminant of this and explain how the sign of the discriminant relates to the sketch in part B. The discriminant, b squared minus 4ac, substituting in, b is 2 squared minus 4 times 1 for a times by 3. This is equal to 4 minus 12 minus 8. In part C, we found that the discriminant is negative. This fits with our graph because the curve does not cross the x-axis, showing there are no real solutions. The final part for today, part D, we're given the equation x squared plus kx plus 3 equals 0, where k is a constant and has no real roots. Find the set of possible values of k, giving your answer in surd form. Let's get a fresh piece of paper. X squared plus kx plus 3 is equal to 0 and has no real roots. Therefore, I know that the discriminant is less than 0. No real root means the discriminant is less than 0. Substituting in these values here, k squared minus 4 times 1 times 3 is less than 0. Tidying that up, k squared minus 12 is less than 0. Adding 12 to both sides would allow me to go about solving this. However, there's something more to consider. In this quadratic here, I know that we've got something that looks like this. We are after the area below the axis because we're looking at less than 0. That means we're looking at a region in between two possible solutions for k squared. If I was to imagine for a moment, just on this line, we're looking at k squared minus 12 being equal to 0, because that's on the line. And that's the threshold that we're going to be having relative for our range. K squared would therefore equal 12, and k would equal plus or minus the square root of 12. We can give that in a much nicer form though. That can be simplified into plus or minus root 4 root 3, evaluating the root 4 as plus or minus 2 root 3. They've not specified the form, but it is better to simplify our surds rather than leave them in this form here. So I know that this point here is 2 root 3, and this point is minus 2 root 3. I know that k is in between 2 root 3 and minus 2 root 3. And that's my final answer. That's the possible range of values for k. So, what I need to do now is check the question. It says find the set of possible values of k, giving your answer in surd form. That's done. However, they might have asked us to use set notation, in which case we would have k, where k is greater than minus 2 root 3, and k is less than 2 root 3. These two conditions listed separately, but it has to meet both of them, so it's and that's the definition of k. This would only be required if they asked us for the set form.